space. Space and lycra. Just space. But that space, even though there's nothing there, is still something. It still does something. And this lycra represents that. Now I haven't had a chance to have a go at this and see how it's going to work yet, but essentially, if you've got mass, you warp the fabric of space-time. So we'll just see what's going to happen if I put one in there. Yeah, I thought so. We're on a bit of a downhill run. But hopefully, it'll work. Try putting that. That's not too bad. Now when you've got mass, you bend the fabric of space-time, and if there's other objects nearby, they feel that, and they're attracted. So this is essentially a representation of gravity. So if you imagine these as being planets out in space, there's one there, one planet there, another planet here. They both warp the fabric of space and time, and they feel that, and they're attracted to it. So obviously, the more mass you have, the more you warp space-time. So let's call this, say, the sun. More mass, the more you warp space-time. And then the little things that are travelling around through space are attracted to it. And if we give our little... Troy's loving it, is he? Yes. And if we give these little things that are moving around through space a little bit of energy, a little bit of motion, we can get them to orbit the sun.
Hey sir, could you use a red one?
What's that?
Could you use a red one for that?
Yeah, we can try with the red one.
Because I'm not picking it up.
Camera doesn't pick that one up, mate. Well, let's see what happens.
There's Uranus.
And so, in this representation, eventually it gets pulled down and crashes into the sun. Space is good, isn't it, Troy? Science! Yeah, you can pretend this is the Earth. But there's a couple of things that are acting on the ball here that don't act on it in space. One of those is friction and the other one is gravity.
Oh, you guys have been paying attention before? Well done. Nice sharing, you guys.
Actually,
so one of my favourite things to do with this is it answers the question that I had not ever wondered until I saw this done. And that question is, why are all the planets in our solar system all going the same way? Why aren't they going different ways? What's that? Yeah, all the other planets in the solar system are going the same direction as the Earth. They attract each other?
That's why they all attract each other, so they all move along.
Okay, so they're going in the same plane?
Yeah, if one's moving that way, they all move that way.
Yeah, right. Well, what I saw for the representation of this is that they weren't all going the same way originally, but the ones that were going the wrong way got knocked out. So let's pretend these are all bits of rock and all kinds of other stuff travelling through space. So they're all travelling around different ways, and the ones that are going the wrong way get knocked out eventually. This doesn't always work. Until they're all going the same way. Well, that is cheating. That's alright, let's see if we can get that one to...
The sun is so big. It's so big. It's so actually light.
See if we can get this one to do that again.
A lot of things fall straight into the sun.
Yeah. same way. Alright. And the other thing that's really cool about this is this stuff doesn't always work, but we can sometimes set up, say, an Earth and a Moon system. And when we get those orbiting around the Sun together, we can try and get the Moon to orbit the Earth. Because the Moon's attracted to the Earth, but as the Earth spins around the Sun, it's creating a little warp in the space-time, and eventually it runs out.
It's going to happen to our maps eventually.
Doesn't matter.
I don't think so. It may do in like a long time, but
You won't stop all of it. That's watching.
now another really cool one is how you can get satellites back to Earth without using much energy. And that's through something they call free return trajectory.
No, that bar.
This one doesn't always work, but let's say this is the Earth and this is the Moon, and the satellite's going to go to the Moon and come back. But there's no BT, there's no Shell, there's no Caltex on the Moon.
How does that attract?
So they try to minimise their energy use because they can't fuel up to return. So they use something called free return trajectory that uses the Moon's gravity to sort of put the slingshot into orbit around it and slingshot it back. So I'll see if I can get it to...
Figure eight.
Yeah, it's essentially a figure eight.
No, mate, I'm just not a fool.
Yeah, we don't really want it to crash into the Moon.
I do physics. Check the
They're lovely.
It could all be like. You could also say that.
I think we might need to... Let's bring the Moon closer to Earth. See if that's going to help.
It's more to scale now.
This worked last time I did it.
Probably the fact that they're both the same
What?
weight. They're both causing an equal distortion in space-time.
Okay, so you think if we had more mass at this end?
Yeah.
What year are you in?
What grade are you in?
Let's test it.
I'm just a slow learner, sir.
That's alright, let's give it a go.
Just started year 6.
I didn't realise the gravity of the situation.
Maybe we need to move further away.
Get Rex Newton.
Took you a while. No, that didn't help at all.
Once again, the theory has proved to be inadequate.
Very good.
Excuse me for my bad Einstein.
There we go, we got it! Incidentally!
Boink.
I feel like I'm doing it too hard. Well, anyway,
Yes, sir.
that's the theory.
I read somewhere that our sun and all the matter that's in our solar system going around our sun, this is the third time that it's the third star that all this material's been in.
Really?
Because in order to get heavy metals like uranium here on Earth, and they're only created in stars, it must have been in a star earlier. So when they say, you know, you like to say, you know, let there be light and all that sort of stuff in the biblical story, this is the third time round. Okay?
Wow.
And you know, everything comes from stardust, including ourselves. Our material was made in the stars. More than 5,000 million years ago. Because that's how old our present solar system is.
5,000 million.
The universe goes back, as far as they can tell, to about 14.9 billion years. And that's 3 stars' life cycle.
Bob, there is a Canadian physicist who wrote a book, We Are the Son and Daughters of Stars.
Exactly, yeah.
That's the title of the book in physics.
Who's got the dark energy?
Pardon?
Who's got the dark? Oh, here, right there.
What's that?
This is dark.
Hanging on to
Dark
dark
matter.
energy.
It only comes out after sunset.
That's right, and we're past that. So
Yeah.
here we go. So dark energy makes things do almost the opposite from what things with mass do, and that is everything moves away from it. So apparently dark energy makes up about 65% of the known
The
universe.
majority of the energy that's around, yeah.
Yeah, which is a large part of why the universe is expanding at such a fast rate. Is this stuff. If you ask me what it is, I can't tell you.
Well, that makes it like the rest of the human race. Yeah, that's right.
Now then, would you feel free to have a play around?
Yay! Science!
As long as no one goes underneath.
Always.
Could suffer a gravity injury.
Yeah, you could get your space-time warped.
It's Jupiter.
So feel free to just grab one as it comes along.
Yeah, I reckon.
3, 2, 1. Science.
Don't lean too heavily on it because it will.
Plenty of carbon.
Yes. Oh, the other way. Why did I have it down?
Oh, yes, I got one.
With 2 guys left.